Question 4, I recognise this from an old Core 1 question because there's lots to it. The first thing you have to do is actually find out what these 2 points are. So you're trying to find out when does this curve meet this line. A little bit of simultaneous equations work. So here's my curve here. Here's the line. Let's just rearrange that to make it y equals 9 minus x squared. And so I've got to try and find out where 3x squared minus 5x plus 3 meets or is equal to 9 take away 2x. Let's add the 2x to both sides and take away the 9. So we get a nice little quadratic there. Why not just solve that quadratic on the calculator? Solving that quadratic on the calculator gives you that x is equal to 2 and x is equal to minus 1. Yeah, so look, there's one of them. We knew it was going to be minus 1. So the other one, when x is equal to 2, y is going to be equal to, we can put it into either of them here. Let's put 2 in there. So 9 take away 4 makes 5. The coordinates of q is 2, 5. So next job is to find out this integral. That's just straightforward. We've got x cubed over 3, so the 3's cancel, minus 5x squared over 2 plus 3x. And that's setting you up ready to suggest how to do the next bit. If we make this integral actually between the values of, that was minus 1, wasn't it? That was minus 1, and that's 2. So if we do this between minus 1 and 2, then that's going to give us this area underneath here. That's not the area we want, but it's that area underneath there. If I work all of that out, I could just tap all that in, actually. That's going to give me 10.5, it works out to be. 21 over 2. Ways of doing that, I mean, look, you are just putting the 2 in. So I've got 2 cubed, take away 5 times 2 squared over 2, plus 3 lots of 2. Work out all of that. Works. I think that works out to be 4. And then the other bit is putting in the minus 1. So I've got minus 1 cubed, take away 5 lots of minus 1 squared over 2, and 3 lots of minus 1. That bit there works out to be minus 13 over 2. And so when I put the 2 bits together, that's how I've got the 10.5 here. That's not the area we want, that's the area of the blue bit. So the area that we're interested in now is this shape here. And you'll remember from your sort of year 7, 8 work, or maybe even earlier, that that's called a trapezium. And to find the area of a trapezium, you need to add the 2 sides together and times by how far apart they are. Half the sum of the parallel lines times the distance between them. That's the way you find the area of a trapezium. So Q, we know the height of Q, we found it earlier, that's 5. We were told the height there was 11, and the distance between them is 3. So half the sum of the parallel lines, that's 16, 16 halved is 8, times the distance between them is 3. So that's the way you find the area of a trapezium. Finally, the area we want, this bit here, that's equal to the 24, take away the 10.5, and 24 take away 10.5 is the 27 over 2, or 13.5 for the area of the bit you wanted.